Mind Matter Media presents Designing Nature's Half, the Landscape Conservation Podcast, where discussions center around the most current and innovative approaches to landscape conservation and design. This is the show for stakeholders who want to adapt to the climate crisis, halt biodiversity loss, and change the world by designing sustainable and resilient landscapes through collaborative conservation action.
Hey everyone, welcome to episode 6 of Designing Nature's Half, the Landscape Conservation Podcast. I'm your one and only host this week, Rob Campoloni. Tom's in Amsterdam on a work-related trip and can't join us for today's discussion. We have a really great show ahead with a very special guest, retired Chief Ecologist for NatureServe, Pat Comer. Pat and I will discuss an essential attribute of landscape conservation design, assessing landscape conditions. When we think about assessing conditions, we typically break that discussion down into current conditions, often described in terms of risk and vulnerabilities, and plausible future conditions, which brings us into the realm of scenario planning. Because LCD is an iterative process, assessing landscape conditions can be done and is often done before or at various times during the design process. But generally, because it's easier for us to think in linear terms, we think of it as occurring at some point after landscape stakeholders have convened and agreed to work together through a design process and before any spatial prioritization or strategic planning is conducted. Logically, that makes sense, right? Because you want that spatial design and strategy design work to be informed by a thorough understanding of the landscape, which is, of course, science. I don't think we're going to get down into the weeds today and talk about integrated landscape assessments, but that's a realm of landscape assessment work that I personally am very intrigued by, and which our last guest, Dr. Ronald McCormick, touched on in our previous discussion about complex systems theory and the need to understand the socio-ecological aspects of a system, which is what integrated landscape assessments try to do. Given the highly technical nature of assessment work, regardless of whether we're talking about integrated landscape assessments or not, the work is typically compiled by or conducted by parties like Pat Comer and NatureServe. But they could also be done by one or more of the landscape partners if they have the ability to do that work. It's not just a matter of turning the knobs and pulling the levers, or in this day and age, banging on the keyboard, but equally as important, having the ability to communicate the results to other specialists and decision makers. So with that as a foundation for how landscape assessments fit into the larger realm of landscape conservation design, Pat and I are going to talk a little bit about the IUCN's Red List of Ecosystems, which he and a few of his colleagues published a paper on in 2022. We'll also talk about another paper Pat and his colleagues published in 2019 about a climate vulnerability assessment that was applied to major vegetation types in the western United States. And finally, we'll discuss yet a third paper that Pat and one of his colleagues, Emily Seddon, published last year on applying vulnerability assessment results to map out zones for adaptation. And we'll provide links to all those papers in the pod notes so folks could easily find them. But first, Pat's bio. Since completing studies in forest and landscape ecology at the University of Michigan, Ann Arbor, Pat has worked for over 35 years on applied research in natural resources management and biodiversity conservation. Most recently, Pat served for over 20 years as the chief ecologist at NatureServe, retiring in early 2023. There, he led a team of ecologists focused on multi-scale ecosystem mapping and assessment often with U.S. federal agencies and the NatureServe network of natural heritage programs. Prior to NatureServe, Pat was a senior ecologist and conservation planner with the Nature Conservancy, first in Michigan and the Great Lakes region, and later in Western North America. There, he developed planning methods and supported 25 teams in completing systematic conservation plans within and across ecoregions in North and South America. As a long-standing member of the IUCN Commission on Ecosystem Management, Pat piloted red list assessments for terrestrial ecosystems across North America and supports the identification of key biodiversity areas with the Key Biodiversity Areas Partnership. Among over 160 scientific publications, Pat published a framework for assessing climate change vulnerability for ecosystems and has advanced his analysis across North America. I want to welcome my friend and colleague, Pat Comer, to today's podcast. It's good to have you here, Pat. Did I miss anything from your bio that you want to add or highlight?
Hi, Rob. Thanks for the intro. I thought that was great. You covered it quite well, and I really appreciate the opportunity to talk to you and with all of your listeners here. I've started listening to this podcast series and enjoyed it very much so far. I think it's really very much needed for these kinds of conversations to be had. So yes, I'm ready to go.
Think first, congratulations are in order, in part for not only having a very accomplished career, but more importantly, for your recent retirement. So, congratulations. Welcome to the free world. Hope you're out there enjoying yourself, Pat, spending time with family and friends and experiencing wonderful landscapes, if not here in the United States, around the world.
Yes, I have been really enjoying this past year after retiring from NatureServe, but then, been keeping my hand in things, working on some papers and publishing some papers. And I'm now back in the United States now. And so we'll see how things develop here this year. Thanks again, though.
Why don't we start today's discussion with a quick introduction to your career as a conservation planner at the Nature Conservancy, then transition to your time at NatureServe and your association with IUCN, and then maybe dig a little deeper into some of your papers and their findings. How's that sound?
Briefly, my training was at the University of Michigan, Ann Arbor, and mainly landscape ecology and forest ecology. I actually did a stint. I kind of wanted to get out of academia a bit and went to join the Peace Corps. I was down in Costa Rica back in the 80s, did some agroforestry and reforestation work before I actually joined the Nature Conservancy, and I was with Michigan Natural Features Inventory in Michigan. It was really part of the network of natural heritage programs that exist in all 50 states and on some of the tribes, as well as in Canadian provinces. And so that was really my original home was with the Nature Conservancy and doing sort of scientific inventory, field inventory work there. And then with TNC, I got engaged very much in the application of sort of systematically developed data, biodiversity-related data, conservation-related data, to conservation planning. And it was really conservation planning at sort of more local landscape scales, sort of the individual sites and how we think through what are conditions on a particular site and how do we prioritize actions on a site. But also, this was back in the, I'd say, mid-1990s. The Nature Conservancy used to do planning, large landscape planning, first at a statewide level. So we would do an annual, we called it a scorecard, where we would get together and assess what did we learn in the past year, what are priority places to do focus on conservation. And it was at that time, like I say, this is sort of the mid-90s when within the Nature Conservancy at least, and many other partners, just advances in landscape ecology, conservation biology were really pushing us to broader and broader landscapes. And that's where the idea of really doing systematic planning within ecoregions really came about. And so as I was working in the Great Lakes region first, and then I moved west. I was the Western Regional Ecologist for the Nature Conservancy. A lot of my job related to developing methods for really what we now call landscape conservation design or systematic conservation planning, but at the scale of ecoregions. And so that was a lot of the effort the Nature Conservancy was pursuing with many partners. I was involved. I was on 10 different teams spanning geographies from Alaska down to South America, in Paraguay and the Chaco, across all the Western ecoregions. So in the United States, there's about 68 ecoregions within the lower 48 states, and each of those ecoregions was a couple-year-long planning process of organizing information, assessing conditions on the ground, and then doing spatial landscape design, as you were alluding to earlier. So that was a lot of my focus at TNC. And then with the development of NatureServe, which really spun out of the science division of the Nature Conservancy around 20 years ago, I moved over to really just focus on that development of systematic, consistent, standardized conservation data and science. So a lot of my work has been focused on how can we engage with larger partners, many federal agencies or national governments in Latin America, for example, to develop information that is suitable and applicable to conservation planning at broad scales all the way down to more finer scales.
Let me follow up with a question regarding your time at TNC. Can you speak to how the work that you were doing at that period in time kind of fit into the evolving field of conservation planning and ecological assessment? How either you expanded on those early conservation planning and assessment processes and helped to evolve those science processes, or just kind of generally, what do you feel as if your contribution was in that work that you were doing?
Yeah, at that time, we were really trying to figure out the process. Had been work in sort of large ecoregion scale landscape planning in different places, like in Australia. There had been work going on in South Africa, for example, and across Europe. What we were tasked with doing was really testing the evaluation of information that we had been developing over recent decades, really, up to that point, and finding out that, there were real needs for mapping distributions of biodiversity, both species and ecosystems. So I focused a lot on that actually led into federal investments in ecosystem classification and mapping. So it was part of the impetus of that was recognizing in order to do large landscape planning across jurisdictions. So this is, like I say, the first time, at least in my experience, we were really moving across state borders and trying to knit together how people had been thinking about ecosystems at a state level, but we really needed a comprehensive view that was not only across states, but across national borders. And so mapping distributions was a major focus of that effort. And then assessing conditions. This is where, systematic methods to really understand how are ecosystems functioning, how healthy are they, at a local scale as well as range-wide. This is where we were tackling. This is some of the most difficult and challenging kinds of work that we were doing at that time to really develop those kinds of methods so that they would be suitable. So we could answer those kind of basic questions of how ecosystems doing, how are species doing, how are species populations doing across a given ecoregion that span different political jurisdictions. So that was a major focus of what we were doing at that time. There was also the point at which some of these priority setting spatial design tools started to get used. So today you'll hear people, utilizing tools like MarkSan or other kinds of spatial optimization tools. Where should we be conserving lands and waters to meet a variety of different goals and objectives? Those kinds of software tools were actually just coming on the scene. And so we were really some of the first in the Americas to really utilize those kinds of tools in a systematic landscape level priority setting process.
So from TNC, you transitioned to NatureServe, where you eventually retired as chief ecologist after 21 years of service. Can you introduce our listeners to NatureServe, the organization's mission, the services they provide, the relationship between NatureServe and the network of state natural heritage programs, and maybe the type of planning that you were doing during your time with that organization.
Sure. So yeah, as I alluded to, NatureServe actually it spun out of the Nature Conservancy. I spent whatever 11 or so years as part of conservancy staff, and we were part of the science division of the Nature Conservancy, providing that scientific expertise and organization of data for use by the Nature Conservancy and their partners. And it became clear around 1998, 1999 that in fact, we were working with everyone else beyond the Nature Conservancy proper, very much a lot of the time, and so it seemed appropriate at that time to spin off. It has a separate non-government organization. It serves as sort of an umbrella for the network of natural heritage programs, which this goes back it's about 50 years now when the first natural heritage programs got established in individual states, and so those serve as, you can think of them as a biodiversity inventory of each state. When I was in the state of Michigan as a program ecologist there, my job was really to know the ecology and the ecosystems and natural communities of the state of Michigan. And that is replicated with botanists and zoologists and other experts, as well as now, a lot of spatial analysts and data managers within every state. And again, as I alluded to, with the TVA, for example, has a member program. Each Canadian province has a member program. The tribes, several tribes have member programs or some strong affiliation. These programs individually were established by the Nature Conservancy, but the intent was they would, find a home in their particular jurisdiction away from the Conservancy. So nearly all now are either in state governments, they tend to be in the State Wildlife Agency, or they're in state universities. And so that's very much the case today. So NatureServe then serves as a bit of an umbrella to communicate and link together all of these disparate programs that really are housed in different agencies across the United States and in Canada. And so the database systems for pooling data across jurisdictions is something that NatureServe does. You can go to the natureserve.org website and you could see people use NatureServe Explorer, for example, every day just to get information about species and ecosystem type. And so it's part of that consolidation, organization, and establishment and refinement of standards for systematic conservation data. And so we call this kind of foundational ecology data that we bring to the collaborations with different stakeholders if we're doing planning or assessment at different scales. So I tend to characterize NatureServe as we're trying to answer a handful of basic questions. I call them the what is it questions, the where is it questions, the how's it doing, how's it changing, and finally, what should we do about it? So what do I mean by that? So what is it? That means taxonomy of species, classification and description of ecosystem types. So that's where we systematically organize this information. It's a continual moving target. That is, our knowledge keeps expanding. And so that's a continuous process of maintaining taxonomies and advancing classifications for ecosystems and community types. Where is it is about inventory and mapping. And so we engage deeply in field inventories. For example, the individual natural heritage programs, as I alluded to, do field work good chunk of every year. They're out in the field documenting locations, especially for particularly rare species and their habitats and where are they located, what are their conditions, as well as mapping and engagement with, say, state, federal, local, but also often federal agencies on mapping. And so I've been engaged since the beginning with, for example, the land fire effort is the interagency program of the federal government with partners to systematically map terrestrial ecosystems with the intent of understanding their dynamics and helping to manage fire regimes, which in several of your prior 4 podcasts, there's already been some discussion about that, how we model and understand the issues associated with wildfire in a temperate context of North America is a big issue. And so we've been engaged providing that sort of expertise in community or ecological system classification so that those become the targets for mapping wall to wall in the country. And so that's the kind of where is it question. how's it doing is that, assessing condition or health of ecosystems, either locally, when I'm standing on the ground, how do I really understand what I'm looking at? Am I looking at a healthy example of a habitat or a community type? And how do I document that? But similarly, we need to look at that range wide. And so organizing information so we can really assess how things are doing from a range wide standpoint. And I'll talk about that more under the example of the red list of ecosystems. How's it changing is where either changes in sort of overall extent or changes in quality or condition or health are taking place. We need to understand those trends. And similarly, this is where we tackle issues of climate-induced change and in some cases, transformation of ecosystems. And so methods and data associated with that comes into play there. And then, like I say, finally, what should we do about it? We provide this sort of systematically developed information to all different partners who are engaged in different types of landscape assessment, priority setting, sort of place-based action, policy-based actions get informed by the data that is developed through NatureServe, its member programs, its partners on an ongoing basis. It's kind of the bread and butter of what these sort of programs and NatureServe does.
Pat, you kind of spoke to the multidisciplinary nature of ecosystem assessments. Do you have any thoughts as to the challenges that are associated with compiling that information from different disciplines and kind of packaging it in such a way that makes sense, that provides more of a holistic perspective of the ecosystem?
Oh, yes. I mean, it is, though, a major challenge just to get on the same page with things like taxonomy and classification, with mapping and inventory. All these are the components, that I view as their inputs into collaborative planning. And so, like I say, a lot of what we have been doing focuses on the collaboration of scientists in a multidisciplinary sense of how do we communicate with each other, how do we work together to organize standard information. And part of that relates to, can we agree upon data standards? And some of those things translate into how we manage information. You have to have databases that can actually accept data from multiple different sources and bring them together into a standardized format. So much of that sort of scientific activity is one of bringing people together within a given field. Let's say they're ecologists who are focused on wetlands, and we have to agree on how we define different types of wetlands. What's the key data that needs to be brought together? So we describe them and map them and assess their condition. This is a scientific process that spans people of different expertise and different geographies that has been, they're longstanding challenges. I've had the good fortune of kind of working sort of north, south, east, and west in the Americas. And so I've had that benefit of being exposed to really different types of ecosystems. But it's very easy. Many people may spend their entire career within a relatively focused geography. And so they're just not exposed to different types of, let's say, species or ecosystem types that don't fall anywhere near their jurisdiction. And so there's a lot of sort of translation and getting onto a common understanding of how do we establish scientific standards. And like I say, this is actually before we even get into that conversation, which is the broader social aspect of how do we do landscape conservation design? How do we engage people in the people who live on the landscape, and what are our collective priorities? This is more the scientific pieces of collaboration that I'm mainly referring to, because this has been largely the focus of what NatureServe has been working with.
The design literature increasingly is talking about the need for us to look at the socio-ecological system as an integrated whole. And I spoke a little bit about integrated landscape assessments in the introduction, but I don't know how much of that is actually being tested or tried. I'm not sure how much researchers, planners, designers are trying to incorporate not only the ecological data, but also social data into a more holistic landscape understanding.
Yeah, I would say, what I've observed through my career has been one of, I remember, for example, in graduate school, folks who were focused on social impact analysis and the beginnings of really social science as a field within a natural resource kind of school, as it was. I was at what was then called the School of Natural Resources at the University of Michigan. I would say through the earlier years I was alluding to with the Nature Conservancy, I would say 90% of our focus was on the ecological science side of things. But what I've definitely observed, I would say in the last 20 years, is very much an expansion of and a work with more social scientists and more ways in developing methods for collaboration that really are more encompassing of different perspectives beyond the purely ecological expertise that we would have brought to the table previously. So I'm generally quite optimistic about the expansion of that. I think it's still happening. It's still early. I don't think we're at the level that we have been for sort of ecological science and development of data standards in the social science realm, that as it's applicable to, say, conservation and natural resource planning and management. But I definitely have seen a lot of progress in that direction. And I think I see it from the non-government organization perspective. We learned a heck of a lot by engaging in Latin America, because conservation within Latin America is much more of a social ecological process. And so there was a lot of deeper experience. I'm thinking going back 25 to 30 years of people engaging in collaborative planning that was very much acknowledging and engaging cultural diversity and cultural perspectives in the process. And so I felt, partly because I have a little bit of background working across Latin America, that we in North America had lots to learn in that realm. But like I say, I think there's much more to do to sort of further integrate that knowledge and that expertise of how do we think about the social aspects of landscape planning. How do we systematize aspects of organizing information in the same way that we have been doing for many decades on the ecological realm?
What if we could rescue the planet from the ravages of the climate crisis and, in the process, save 1 million species from extinction? Would we do it? Former U.S. Fish and Wildlife Service Senior Policy Advisor for the National Wildlife Refuge System, Robert Campoloni, explores the United States' most pressing conservation challenge since Rachel Carson's Silent Spring, the triple planetary crisis: pollution, climate boiling, and biodiversity loss. In Designing Nature's Half, a practical guide to conserve 50% by 2050, Campoloni reveals previous nationwide initiatives to design sustainable and resilient landscapes, provides an easy-to-follow how-to guide for taking a collaborative, science-based approach to identify conservation actions across large landscapes, and advocates for taking a third nationwide try to design nature's half. Learn how to take a synergistic approach to mitigating the climate crisis and conserving biodiversity in Designing Nature's Half, a practical guide to conserve 50% by 2050 and be part of the global movement to save the planet. For more information, visit www.designingnatureshalf.com.
I guess I'd like to shift at this point, Pat, and focus on a few of your papers. Why don't we start with your 2021 paper in Conservation Science and Practice titled Documenting At-Risk Status of Terrestrial Ecosystems in Temperate and Tropical North America. You and your colleagues applied 4 IUCN Red List of Ecosystem criteria to 655 terrestrial ecosystems in North America to gauge the probability of range-wide collapse. The findings are quite alarming, but can you speak to the IUCN Red List of Ecosystems and tell us a little bit about the study?
Sure. So, in the IUCN, just for listeners' background, the International Union for Conservation of Nature, it was established in a post-World War II realm. The headquarters is in Europe, but there's actually members of IUCN being non-government organizations as well as governments. The U.S. government is a member of IUCN, as are other NGOs like NatureServe. IUCN has been around focusing on sort of global standards for understanding biodiversity and conservation all this time. Many people are familiar with the Red List of Threatened Species that was established by IUCN, I believe over 40 years ago now. And it's the common sort of global way of determining if species are critically endangered, vulnerable. These are categories, standard categories: near threatened, least concerned. Now, I should say, NatureServe has had a parallel sort of program or framework for doing that sort of status assessment. It's one of those ways that we answer that question of how is biodiversity doing, and that is, people may be familiar with global ranks of relative imperilment status, and so NatureServe also for the past 40 years or so has actually been engaged in this kind of assessment, organization of information around this. But it became clear, I would say 15 years ago or so, that we really needed a more rigorous framework for assessing ecosystem types in the same way or in a parallel way that we were thinking about individual species and establishing a status assessment. And just to back up, when we think about this from a range-wide standpoint, we should ask, why do we do this? Well, part of this is getting at, we're trying to get at a relative risk of loss. That's what an assessment, a status assessment, is really about. And what it does as it translates into landscape conservation is, first off, what it tells us, it gives us a relative sense of urgency of action. If we're talking about something that's critically endangered, we really have few opportunities to conserve that species or ecosystem type. And so we urgently need to take action. Whereas something, if it scores as, let's say, least concern, we actually have many different options in terms of conserving that type of species or ecosystem over the long term. And so first and foremost, like I say, a status assessment tells us a lot about urgency of taking conservation action. And so it was about, like, say, 15 years or so ago, I've been on a member of what's called the IUCN Commission on Ecosystem Management. And through that commission, experts from around the world, we got together, started reviewing how people had approached it in different countries, and then started to organize and structure a global standard for assessing ecosystem types that, again, would serve as that parallel to the Red List of Threatened Species. And so just at a very high level, I want to talk about, there's some of these aspects we get at measurement of trends over time, over several different time frames, over the past 200 years, or the past 50 years, or the next 50 years, or changes to ecosystems in extent, or changes in condition or that health, looking at both abiotic as well as biotic ecosystem components. And so these are the sorts of analyses that are required for us to get a handle on what are the, what's the status of different ecosystems. Now, we have been very fortunate that, especially in North America, we have focused a lot on ecosystem classification, especially, say, terrestrial ecosystems. What do I mean by that? Upland types, forests, grasslands, shrublands, as well as wetland types and riparian or floodplain kinds of communities. There has been much work in freshwater communities as well as coastal marine communities, but there's been much more work in the terrestrial realm. And so that's actually what we focused on for this initial application of the IUCN criteria in North America. But just to touch on this, in terms of mapping and mapping distributions, it's only been the last 20 years or so where the advancement of satellite imagery or other forms of remotely sent data has been really available to allow us to map ecosystems, terrestrial ecosystems, at levels of detail and reliability that were far beyond where we were, like I say, just a couple decades ago. So increasingly what you see is the organization of data and the use of tools for it's machine learning. Increasingly, you hear, people using AI. Well, yes, AI is a part of actually making maps, of actually organizing observations of different types of ecosystems that we have classified and described, millions of different observations, combining that with different forms of of satellite remotely sensed data to actually map their distributions, both their historic potential extent as well as where they are today. And it allows us, this is, like I say, something we've only been able to do in really recent years. And so we're fortunate to be in this position to work with, let's say, 655 different upland and wetland ecosystems in North America. This analysis focused from temperate Canada, so southern Canada, all the way down through Central America and the Caribbean. So those are 655 different types of, like I say, forests, grasslands, shrublands, different types of wetlands, coastal community types. Those were the focus of this analysis. When we get into that assessment of trends, so some of this is change in extent, how much have we lost? We've converted a lot of North America for agricultural land uses, urban land uses, other kinds of land uses. That makes up and explains a lot about the status of terrestrial ecosystems in North America. There's also been more recent trends. So that is, we want to understand, are some parts of the landscape really experiencing land conversion just over the past 50 years? So that's another form of measurement that is essential for getting a status. And then finally, we're actually trying to look out over the sort of a 50-year window, looking into the future, and see what does that inform us about the nature of trends. And again, what we're about is getting at a sense of relative risk of loss, ecosystem type by ecosystem type. So when we get at condition, this is where some of those the previous podcasts and Ron McCormick's reference to modeling of wildfire comes into play. The data from ecological site groups or landfire that create these, we call these state in transition models. What is the succession and disturbance patterns for each of these types of ecosystems? We have a lot of well-documented understanding of all these different ecosystem types in terms of their natural disturbance regimes, so that we can compare that against the current distribution, the current structures that we observe on the landscape, and we can now see and quantify where our effects of fire suppression, for example, come into play, where effects of invasive species altering fire regimes comes into play. And so these are really important measurements that tell us a lot about what is the current status, what's the current condition and health of ecosystem types. And so we are very fortunate in the United States, at the very least, that we have this wealth of data that we can bring to the table, apply these different criteria that we've established under the IUCN framework, and consistently come up with a score. And so overall, with our North American study, well, what we could see is about 33% of those 655 types fall into one of these categories of vulnerable, endangered, or critically endangered. Now, some of these major patterns we have known about quite well. As I alluded to, we say the Midwest is kind of the breadbasket of the world. Well, our prairies, our tallgrass prairies in particular, have paid the price for that. So some of this is not a big surprise. Earlier in the 20th century, there was a lot of wetland conversion, drainage of wetlands mainly for agricultural land uses, and so many wetland types have declined in their status due to outright conversion and drainage of wetlands. Our eastern forests were much of the eastern United States was converted for agriculture, but we're actually seeing a bounce back in many different types of eastern forests, that there is a regrowth of forests with urbanization that has been happening. So these are kind of long-term trends that we could see, but we could see in a much more precise way now that we can apply these criteria with current kind of data. The other major finding of this analysis, which I find very intriguing when we think about landscape conservation design, is approximately 30% of the current land area of this whole study area in temperate to tropical North America currently supports ecosystem types that fall under this vulnerable to critically endangered ecosystem status under the red list. And so it gives us a lot of a sense of places where, again, there's an urgent need for ecological restoration in different parts of the North American landscape. And so we know what they are, We know where they are today based on this more updated kind of mapping capabilities. And we also know a lot about how they have become really degraded and altered. And so we have an accumulated set of information that is very informative towards thinking about strategically about landscape conservation design that will help us restore and recover many ecosystem types that we know are at the very least vulnerable to complete loss.
So that's a great segue then into your next paper that I'd like to talk about. And that's your 2019 paper titled Habitat Climate Change Vulnerability Index Applied to Major Vegetation Types of the Western Interior United States. I'll cut you loose here, Pat. Run with it.
Sure. So similar to that and sort of parallel to thinking about the red list of ecosystems where there was an existing assessment protocol for species, but we felt that we needed to develop something that really dealt with the complexities of multiple species interacting with their environment in some different form. You just need to think about the entity differently when you want to do an assessment. We felt the same way about climate change. That is, previously, NatureServe, many other folks had developed what we call vulnerability assessment protocols for species. And those had been, on the ground, people utilizing them. But it was around 2010 or so where we started this process. We actually had support from the Fish and Wildlife Service to get ourselves going on this. And we organized expertise and then developed a framework that has parallels to the assessments for species. But like I say, you're going from, we would say, is really audecology for the biology and ecology of individual species and how they interact with their environment, to synecology, how do multiple species in different environmental settings actually interact. And these are what we say are communities. So you have to think about different components differently. But we sort of settled on the basic framework that is common in many climate change vulnerability assessments, where there's some measure of climate change exposure. That is, the climate is changing, and so what's its effect, its direct effect on the community, the ecosystem type at hand. And then we also compared that against measures we call resilience measures. And these have two different pieces to them. Some of them are, we call them ecological condition or sensitivity measures. And those very much relate to those other kinds of things we use for status assessment. The ecological condition or health of a particular ecosystem at a given place is relevant in a climate change context. And the other is we call adaptive capacity of a community or ecosystem type to climate change. So given the same kind of increment of climate exposure, there are different resilience measures that we're going to bring to the table. So adaptive capacity we think of in a couple of different ways, and that are really new. We haven't actually, as ecologists, been thinking about these things in the same way. That climate change has sort of forced us to think a little differently. So I would characterize these as sort of abiotic ways of thinking of adaptive capacity. And if you think about, let's say, vegetation on the landscape, if it occurs on a very flat plane, and so just the topography where particular types of communities and ecosystem types exist, for the same increment of climate change, you got to think about the need for species, individual species that make up that community are likely to need to move a greater distance for the same increment of change, as opposed to if something occurs in a very rugged landscape, that there's likely to be many microclimates within that rugged landscape, and therefore individual species likely will be able to move, so to speak, within and stay within their sort of climate envelope than they would if it were more flat landscape. So that's an aspect of adaptive capacity that's purely abiotic. It's where do the communities sit in the landscape. The other is biotic. That is, what are the species, the different roles that species play within communities? And this is where it sort of forces us to think about the functional roles that species play. Let's say nitrogen fixing plant or others that serve different kind of purely functional roles. It's not so much about, is it a rare species? Is it a trust species in a Fish and Wildlife Service perspective? No, what's the functional role that a species is playing in a given community type? Because we know with climate change, we're going to lose individual species. We don't necessarily know, we don't know very well which ones we'll lose, but we want to know if there's sort of let's call it a functional redundancy. That is, there are multiple or many nitrogen fixers, or there are just a few nitrogen fixers. If in fact there's only one nitrogen fixer, you would start to say, well, maybe we have a keystone species. I really want to understand the relative climate change vulnerability of that species, because it's going to tell me a lot about the vulnerability of this overall ecosystem. So these are some of the aspects that we bring together. For climate exposure, we're looking at temperature, precipitation, kinds of variables, seasonality variables, and how they have changed since basically the mid-20th century as a functional, practical baseline. And so, we want to know practical things. Is it getting warmer and drier? Is it getting warmer and wetter? What are the projections that we can actually utilize from the accumulating and advancing, it's rapidly advancing climate modeling field? And so we want to understand that. We only look out the next several decades, because you just look at error ranges of models as you look out to, let's say, the end of the 21st century, or a 2100 projection. The error bounds are really quite wide. And so all we tend to do with a vulnerability assessment when we measure exposure is just look out to mainly the mid 21st century. Compare that against roughly the mid 20th century to understand the magnitude of change amongst different climate variables. And so what we've been able to do so far, we did that initial analysis. It was supported by the Bureau of Land Management. We did analysis of over 50 major types that occurred on BLM lands in the Western United States. And then since then, there's been another 50 or so types have also been assessed across the United States. So there's a lot of progress in terms of an initial assessment. And what we really see is, one, the geography of vulnerability varies across space and across time. That is, what I mean by across space is that, let's say we have a different type of sagebrush. Well, different types of sagebrush, they can occur over hundreds, thousands of square miles. And so maybe on the north end or the east end or the south end, you might be scoring much more significant vulnerability than you might in another part of the range of a type of that sagebrush type. And so there's just diversity and variation across the distribution of individual types is something that we see coming out of this sort of analysis. But first, what we see is we want to track this over time. And so what we could sort of see right now, we started to do analysis, apply our criteria to all different types with just sort of emergent patterns of climate change with data, climate models up through today. Our first analysis was just looking at climate changing as of 2014, and then look at those as you go out towards the mid-century. And what the basic finding and way to think about this is that, climate is changing. It's changing in a highly variable rate from place to place, but overall, are applying our same criteria, most types scored in sort of the moderate vulnerability range today. You would say that today, based on the degree of actual climate exposure. And much of that moderate vulnerability comes from the fact that our resilience scores, that is, we have degraded and altered ecosystems across North America to varying degrees, and that explains a lot of the current vulnerability. But then as you move out and you look out towards the mid-century, then you see more types, many types, a larger proportion of types start to score in the high to very high vulnerability range. And that is really just the compounding effect of increasing climate exposure combined with those measures of condition, or we call them overall, resilience measures. And so, our bottom line from this kind of analysis is we make investments today to restore or maintain ecosystem health. These are important responses to climate change vulnerability. So we don't need to hesitate too much about doing maintenance and restoration of ecosystem health and condition, addressing many of the issues of fragmentation or invasive species or alteration to those natural disturbance regimes. That's a good investment today. as an initial hedge against and to hopefully be reducing climate change vulnerability over upcoming decades, and that we can see, and we can see in places greater and greater climate exposure is beginning to occur and is projected to occur using the latest of climate modeling and climate science, that we can begin to think more and more about, well, what is the task that we were going to have if we can maintain and restore healthy ecosystems. Undoubtedly, in many places, they're going to continue to change. They're going to be under greater stress and climate stress, and we need to understand the nature of that stress so that we could respond in the most effective ways.
I think we have time for one more paper, Pat. I'd like to hear your thoughts about your 2023 paper titled Climate Change Adaptation Zones for Terrestrial Ecosystems. You used NatureServe's Habitat Climate Change Vulnerability Index as part of that study. I don't know if you want to focus just on the index or speak to the overall studies, but I'll leave that up to you. So take it away.
Yeah, I'll focus very much on the follow-on, and we call this sort of just think of it, adaptation zones, and that is, we do vulnerability assessments, but the reason we do this is because we really want to inform what do we do about the nature of vulnerabilities that we're able to document and clarify. And fortunately, there's been great thinking that you're certainly aware of about how do we begin to cope with and think about adaptation. And there's different frameworks coming online to help us sort of organize our thinking about what is the appropriate response to a changing climate and climate stress. And so the purpose of this analysis was we just focused on pinyon juniper woodlands as more just a documenting an illustration of a process of how would we organize this information that comes out of the vulnerability assessment to turn into something quite practical for planners and managers. And when I think of this, it's really, we're really fortunate to have mapped things, because if there's one aspect of something I could give someone that is practical, if I could give you a map that gives you some good suggestions about the management emphasis for adaptation, that is received eagerly by many planners, many managers, that they really appreciate something as concrete as a map that gives them some insight. And so when we think about those responses, there are a variety of different publications associated with thinking of adaptation responses, but I'll just boil it down into sort of three generalized categories. There, in fact, are more categories, but let's just think of it this way: as resistance versus sort of resilience-based strategies versus transformation-based strategies. And so, what do we mean by these kinds of adaptation responses? A resistance strategy might be, let's take a coastal ecosystem, and you're anticipating a bit of sea level rise or change in coastal dynamics. You might harden the shoreline. You're really kind of resisting the change, is what you're doing with some measures there. Resilience, for that same shoreline, we might be saying, well, let's restore some of the coastal wetlands so that we can be resilient to the changing sea level rise and coastal dynamics and coastal disturbances. Versus a transformation kind of strategy in that same shoreline, we might be saying, we really need to construct a whole new shoreline to cope with the magnitude of change that we can foresee. And so that the questions become, what kinds of strategies are appropriate? Where would we actually implement these kinds of strategies? And actually, a very important thing is the temporal dimension. By when? We don't want to rush into implementing something based on an estimate of change that really is not likely to take place for several decades, perhaps. And so we need to think about the timing of this too. So what we were doing with this analysis and these examples is really looking at the patterns of vulnerability for each of the pinyon juniper woodland types. And again, there's exposure measures, there's those resilience measures that are all quite useful to then think in a practical map-based, standpoint to say, okay, can I actually fit generally speaking, into more of a resistance end of the spectrum or a resilience end of the spectrum? Or, gosh, do we need to be thinking about transformation-based strategies soon, like within the next decade or so? So first, it's a little bit of a categorization of the different kinds of adaptation strategies, a whole family of strategies that we might pursue. And then we utilize the actual measurements that we used in the vulnerability assessment. Those things mainly based around what I call the resilience measures that got at fragmentation, they got at invasive species, they got at alterations to natural disturbance regimes. And those then inform a bit more the nature of adaptation work that is needed within a given geography. And so what we were doing is looking out into the upcoming decades across different pinny juniper woodlands. And we could say by, and categorizing these different zones for each type, just a handful of different mapped zones for each type that gives an initial input to planners and managers as to this is what we're probably up against in terms of managing pinny juniper woodlands within a given jurisdiction. And so our results initially were saying by mid 21st century, it's anywhere at 3 to 23% of the combined area of these types within the United States was categorized as either directed transformation or autonomous transformation. This is kind of digging into the details a little more. But that's sort of, there's going to be transformation there. We're either going to sort of connect the landscape and let species move around themselves, or more directed transformation. We're going to need to take some directed actions, but transformation is likely to be happening within this time frame. Just 10% of the combined area of these types really categorized into the more of a passive resistance strategy suggested. That is kind of, just business as usual. You're doing fine. You're kind of in a typically very isolated area, and the degree of climate stress seems to be manageable without needing to change your current approach to management too much. That just applied to 10% of the landscape looking out over upcoming decades. So this is some of what we were working on, is how do we organize information so it could be informative to planners and managers? They could start to think about budget allocations. We spend an awful lot of money on public lands, managing vegetation and habitats. And so the ways that we can organize our information to be more efficient and targeted and focused as what is the right response that will give us the maximum benefit from the standpoint of actually conserving biodiversity under a changing climate. This is an increasingly urgent thing for us to do.
Well, Pat, I'm afraid we're running out of time, but it's been great having you on as a guest, and it's been a great discussion. Thank you so much. Do you have any parting thoughts that you'd like to share with our listeners before you go?
Throughout much of my career, I've been able to, and I've had the real pleasure of working with public land managers and land use planners like you, Rob. Yeah. And I have to say, I just want to shout out to the public land managers and planners. They have a tough job. The task of really engaging people, engaging a lot of information in planning processes is no small task. And they are people to be admired because as things have gotten more complex and in many cases more controversial, more polarized, it's just a very difficult job to corral people to get onto a common framework. But it's absolutely essential. Conservation is really complex. It's really challenging. It really should not be polarizing or bipartisan by any means. It's all about our collective future. So we all really need to take responsibility and work together. And so, that's all my parting thought for today. And I just want to say, thanks again for the opportunity. This has been great. I've been enjoying your podcast, and I'll continue to engage on these.
Okay, well, thanks to our guest, Pat Comer, and thank you, our listeners, for tuning in this week. Join us every 2 weeks for another informative episode of Designing Nature's Half, the Landscape Conservation Podcast. I've been your host, Rob Campoloni.
Designing Nature's Half, the Landscape Conservation Podcast, is researched, written, edited, and produced by Rob Campoloni and Tom Mewald. Lucas Gallardi created the Designing Nature's Half cover art and logo design. Tom Askin is the voice behind the intro and outro, and the music was written and performed by composer Alexei Kistlin via Pixabay. Designing Nature's Half, the Landscape Conservation Podcast, is a proud member of Mind Matter Media, a startup multimedia network whose mission is to change the world by designing sustainable and resilient landscapes for people, planet, and prosperity.